students. Today we have Proposition 4 in Book 3. Proposition 4, Book 3. If in a circle, two lines not passing to the center, not both passing to the center, cut one another, they do not bisect one another. That is to say, they're both not bisected. If in a circle, two lines cut one another that don't both pass through the center, they do not bisect each other. Here's our circle. Here are two lines cutting one another. I say that it's impossible for this line and this line, this line to be bisected here and here, and this line to be bisected here and here. Maybe that's been bisected, but they're both not bisected. How can we know that? Okay, let's go by way of reductio ad absurdum. Let's say they do bisect one another. Okay, and we know that if two lines bisect one another in a circle, the line dropped perpendicularly, the line cutting through them from the center cuts those lines at right angles. We've proven that in a circle, if a line be bisected, then the point of bisection and the point of the circle with a line drawn, that line will be dropped at right angles to that line which is bisected. So if there's a line, we know it's bisected, we drop a line between the points of section, then that it will be dropped perpendicularly. We proved that, so now we know it's so. So if this is bisected and this is bisected at this very same point, then this line falls on this line perpendicularly, and this same line falls on this line perpendicularly. Okay? So then this would be let's go over here. This would be a right angle. Maybe it is. And this would be a right angle. Okay? So we got a problem here. We got this being a right angle and this being a right angle. Therefore, they're equal to each other. This angle is equal to this angle necessarily. And then because two things are equal to each other, they equal the same thing, they're equal to each other. Two things equal the same thing are equal to each other. If both of these are right angles, then they're equal to each other. That is to say, the part of this whole angle is equal to the whole. And that is ridiculous to say that this thing, which is a part of this thing, is equal to it, because the part is less than the whole. So this thing would be both equal to this angle here, would be both equal to the other angle, and not equal to the other angle. And as we showed before, in reductio ad absurdum, we grant something, we know it's false, we think it's false, we grant it, we see other things that necessarily follow, and we get to an absurdity, that something can equal something and not equal something at the same time in the same respect, be and not be. That's ridiculous. So the thing we granted must be false because these other things are all true, so the thing we granted must be false. So it must be false that these two lines, both that are not passing the center, that they both bisect one another. And the same thing would happen with any two lines. Okay, same thing, drop it, and you see that this would equal what? That this would equal this, say, something like that. And you get the same problem every time, that the part is equal to the whole. Okay? So we have shown by way of reductio ad absurdum that if in a circle, two lines not both passing through the center cut one another, they do not both bisect one another. They're not both bisected. Impossible. One of them, for the set, can be, but they're not both bisected. Quod erat demonstrandum. Thank you. Bye.